this meeting. So MA Lagos welcomes you all to the general chat. What is So you are all welcome to the general chats. And as we usually have it, these are our ground rules. And the first one is to please be respectful to everyone in the session. Yeah, it will be an interactive one, but please let's be respectful to everyone and create a welcoming, supportive environment. Let's mind the way we speak to others. Also, you have to keep your microphone muted. Just like I stated earlier, you have to keep your microphone muted unless you are speaking or asking a question to minimize our background noises. Also, you have to engage actively by sharing your thoughts. Let it be free. Nobody is watching anybody. It should be a free session for all of us where we can speak up what's on our mind and stuff like that. Also, we have to speak one at a time. One at a time. If you see someone speaking, just hold on for the person to be done before you go on with yours. So ensure that everyone has an opportunity to share their thoughts without interruption. So it won't be as if I don't have my time to like speak up what's on my mind. Also, we have to keep discussion focused on machine learning, AI, and the topics on the agenda, which is our study group topics. Also, we have to avoid spamming the chat with irrelevant links. Don't advertise your products here. Yeah, so this is not an advertisement site. So that's also one of our ground rules. And the next one is to join the session on time. So I think most of us have already joined and stay until the end to gain the full value of the events, yeah, of the interactive section. So feel free to ask questions. Don't be feel free to ask question. You surely get an answer to your question. So, and also most importantly, have fun and enjoy the session while connecting with others in the community. So after saying all this, then we can move on into sorry, please, I think are we getting is ML Lagos, please can you help us record the presentation? Is it being recorded already? Just a thumbs up and do for me to continue with our topic of today. Hello, ML Lagos, are you here? Come, let me check up on her so she can help us record the meeting. I'm coming. Sorry for the interruption. I'm coming. So I'm just holding up for us to join our meeting for us to post recording meeting for that to have and I want very interactive and stuff. Yeah. So let's just move on to the next topic of today. So what are we talking about today? What will we be talking about for today's interactive session? So the first topic we'll be talking about is the introduction challenge. So we'll be having the introduction challenge, the innovative idea, and also we'll be sharing a fact or a fiction section, and also we'll be having our breakout section. So after all the topics of today, we'll be having a breakout sections for us to specify on the okay, yeah, she said she's ready recording it. Thank you very much. So we'll be having a breakout sessions for us to attend to the past topics we've treated. So in light of that, I would like us to just specify we need like 5 students from each groups. So I want us all to specify in the chat box the group you belong to. I think yeah, this is a mix. This is a general chat. So I sent this group to the GenAI student, also the GenAI groups. So I think we have the GenAI and the basic ML here. So I want us to specify on the chat box right now the group you belong to. Yeah, just specify ML, then GenAI, ML, GenAI. Thank you very much, Inashi. Okay. We have 16 candidates on the call right now. Thank you very much. Thank you very much. ML basics. Okay. Come in, let me check how many we have already. Okay. 1, 2, 3, 4, 5. Oh, so we have 5 out of 16. Okay, minus I and ML and then one of our representative. I think that's 3 minus 16, that's 13. So we're expecting 13 responses. Please let's make it very snappy so we can move on to the next section. Yeah, just specify ML basics or just GenAI. We're expecting 13 responses and we've gotten, okay, so I think I should start calling names if you guys don't mind, because it's just response of your group. So Inachi has dropped, Faith Chinichirima dropped, Kenochukwu has dropped, Emonemawe has dropped, Michael Olomo has also dropped his own. So for the people remaining, I'm coming to check. Mr. Abdullahi Adeni, can you please specify the group you belong to? Thank you very much, Ego. Mr. Abdullahi Adeni, can you specify the group you belong to? Is it ML Basics or GenAI? Just type that in the chat box. Also, Miss, is it Miss, oh yeah, Miss Adepiton Oluwatosin. You can also help us with that. John Adere, thank you very much. Yeah, James Emiade, yeah, ML Basics, ML Basics. Kene Chukwungo, got it at that. Maureen Ayanwu, please, can you help us with that? Which group they belong to? All right, Miss, okay. James Emiade, okay, that's fine. Maureen Ayanwu, I think we've not gotten from Lisa. Okay, I think we have Taufik Taker. This someone is even using a chat box. All right, no problem with that. So I think all we have right now is just the ML basics, and we need some Gen AI for us to continue. At least 2 Gen AI students should be here. Come, let me go to that chat. Let me go to that chat. Just 2 minutes. Sorry for the delays. All right, yeah, welcome, Mr. Mejabi. Oh yeah. So can you please help us with the group you belong to? Is it ML Basics or the Gen AI group? Just help us with that on the chat box. Yeah. Okay, our speaker is here, Mr. Gundele Olawale. Yeah, I'll be introducing him very soon. Thank you for joining, sir. So any other person, can you please yeah, I still there. Okay, Mr. Oyelabi, welcome to ML Lagos General Studies Group. So I'll be liking you to please help us with the group you belong to. Is it the ML Basics or the Gen AI? Mr. Oyelabi, we are expecting your chats.
ML Basics. ML Basics.
Oh, ML, thank you for that. You can put it in the chat box. Thank you very much. Thank you. So I don't know how we should move on with this because it's a general, and like at least I should get at least like 5 students from the GNI. That's at least, but I can still move on with 2 students from the GNI. And with the current status, I think all we have here is still the basic, yeah, ML basic, ML basics, ML basics. Coming. Although you guys are much populated than they are, so I think that should be the reason. But that shouldn't be a reason why none of them should be on the meeting right now, because it has been communicated earlier. I'm coming. Maybe the study group. Okay. All right. Yeah. Welcome, Mr. Praise. Sorry, please, can you help us with the group you belong to? Is it the ML basic or the GNI? Mr. Praise, thank you for joining. I said, can you please help us with the group you belong to? Is it the ML basic or the GNI?
Okay, okay, I did not
Yeah,
get that earlier.
you can say that one.
Okay,
All right, no problem.
yeah, basic.
You can help us on the chat box.
Okay.
Basic also. All right, just put it on the chat box. Thank you very much. Chat box. Okay, so I think I'll be changing the scope of the meeting because it's 10:18 already. What was the essence of meeting till then? Oh yeah, sorry for that, Mr. Oh wait, yeah. So the hold up, yeah, the hold up was that we're expecting some GNI students to join the meeting for continued course. The interactive section will be between the basic and then the GNI. So since we are not having them right now, what we'll be having should be an interactive session between the ML basic students, because that's what we have on the group chat right now. So in light of that, we'll be moving on to the next slide. So for the introduction challenge, coming. Yes. So for the introduction challenge, the initial routine was to like select 5 candidates from each groups to summarize the topic from previous weeks. But since we are not having them on the call right now, I think we have to do what we have, and that's the ML basic. So I'll be getting randomly selecting 5 candidates each. Yeah, and yeah, we're forming a group of 2. Yeah, we're forming a group of 2 within the ML basics, and then the group of 2, yeah, we'll be having students, like, just let me just bring that the first go down to like 3. Yeah, 3 is okay. 3 candidates from each group that I'm being split right now should be able to summarize the topic from previous weeks. So in light of that, I'll be doing this explanation right now. Coming. So the first response I got was from Miss Onyechi. So Miss Onyechi, I'm sorry for pronouncing the name anyhow, but I'm sorry. So Miss Sandra, let me just use that. Miss Sandra, and then Miss Nwogu, and then Miss Faith, and then Mr. Mr. Owe, yeah. So I think 1, 2, 3, 4, and maybe one more, and then Mr. Michael. You all are in a single group, and then Mr. Egbo, Mr. John, and then Mr. Maureen are also in the group. I think that makes it even. So from that, we'll be having the next. So 3 minutes per candidate. So you guys will be having 3 minutes to give us a brief summary of what you've learned for the past 2 weeks. Just a brief of what you've learned. It's not compulsory for it to be the way it was from the study resources and stuff like that. Just give us the way you understand it. Just give us a brief summary. Like I'm saying, brief summary. Just give us a summary of what you've learned for the past 2 weeks. So, should I start with group 1 or group 2? I'll be starting with group 2. Thank you very much. So, Mr. Maureen, yeah, you're the first candidate. So, can you please give us a brief summary of what you've learned for the past 2 weeks? Just 3 minutes talk. Not Yeah, it doesn't have to be perfect. Just give it out the way it is. Just let us have a very nice environment. Mr. Maureen, I see you. So, all right, all right. Hello, Mr. Maureen. So, anybody from the group of Mr. Maureen to help him out? Anybody from his group to help him out? Hello. It's not, you guys shouldn't take this very serious. Just say it the way you can say it. It shouldn't be too technical, and you don't need to be perfect. Just give it out the way it is, the way you understand it. And if it has to be corrected, then we can go through that in our second breakout session. Okay, Mr. David, you say you are in. Sorry, can you please tell us in the chat box? Okay, I think you're from the Gen AI. Just signify with an emoji that you are here right now. Or you are in the, oh God, probably you are in the breakout session group. Mr. Maureen, we are still expecting your feedback. So you have like 3 minutes to just gather up what you can. Mr. Maureen, time is almost up. Should we give it to the next group? Okay, I think Mr. Maureen is now available to answer the question, and there is no one from his group to also support him. So we're moving on to the next, which is Miss Sandra. Miss Sandra, can you please give us a summary of the lectures you have for the past 2 weeks? Just a summary, nothing too much, just a simple talk about the studies you had for the, even if it's your experience, you can also share it here. Miss Sandra, you guys are not responding. This, oh God. Okay, is it because we said the meeting is being recorded? It's a very free stuff. Just say what you have in mind. Nobody is perfect. Nobody is correct. Everybody has their issues. Just give us what you want to give us. It's not necessary for it to be perfect. So your 3 minutes has 2 minutes left, Miss Sandra. So in aspect, if you should like skip up on the time so we can move on to the next group. So you still have 2 minutes left. Miss Sandra, yeah, we're expecting your feedback. Wait, are you just joining, Miss Sandra?
Check the chat.
Hello.
Check the chat.
All right, all right. Okay, I'm unable to speak. My microphone is blocked. Okay. Please give me 1 minute to join my phone. Okay, yeah, thank you very much. So 1 minute to join with your phone. Okay, so you have an extra 1 minute on that. Okay, you've joined again. Thank you very much. So
Can
can
you
you
hear
help
me?
us with, yeah, we can hear you very well.
Okay. Actually, I don't know what's
Yeah.
on my
Okay, a
computer.
list of
Lock
members for your group. Okay.
now to speak. So personally, last week, I dive into the week one that is about ML fundamentals. So I'm currently in vectors where I learned about the multiplication, addition, and subtraction of vectors. So for the week two, that's the calculus. I have not started actually, so I'm still in that week one. So personally, the issue I'm having with that particular resource is that it actually breaks down the maths there, but there is no like um personally I've gone through this video so many times, but application is where I find it very difficult to scale through. Because first of all, after learning all this now, how then do I apply it in what I'm doing? How then do I make it sync so that I will not forget it again? Because I can remember this is the third or fourth time I'm actually watching these linear algebra maths fundamental videos. So personally, this weekend I plan to finish up one to week two courses. That's the resources, and then by next week I then move to the next one, which is the Python library for ML. So that's it for my end.
Yeah, yeah. Thank you very much. Thank you very much for that. So please, let's appreciate that. She just gave us some of our points right now. So I think, yeah, thank you very much. So in light of that, we'll be moving on to the next group. I'll be sending in the list of the group again for you guys to be able to access them. So I'm coming. So next person would be Mr. John. Yeah. Mr. John, can you please help us with a summary of your experience or what you've learned for the past 2 weeks? Mr. John Areola J3Ek. Yeah, that's J-Tech. Yeah. So please, if you is yours. Group two, you guys already missed the point from Mr. Maureen. Mr. John, you can still save the group two. Please say something. Okay, you still have 3 minutes left. Mr. John, we're expecting your summary. 2 minutes left. It doesn't have to be perfect. Just give us what you have. 1 minute left. Okay, so I think your time is almost up. You have seconds left. Okay, so I think your time is up, Mr. John. So we are moving back to the group one. So from the group one, Miss Sandra has helped us with some points. So we are moving on to Miss Faith. Miss Faith Chinechirem, can you please help us with a summary of your experience or what you've learned for the past 2 weeks?
Okay. Good day, everyone.
Yeah, good day, Miss Faith.
Okay. For the past 2 weeks, although I've not gone through the second week, which is calculus, but for the matrix, I've been able to go through it, going through the multiplication, addition, Cramer's rule, and all. I was able to find out that the mathematics we've been learning right from secondary school, that it can be applied in machine learning. Because watching that video, I found out that using the graph the tutor was using was actually very applicable, because it can be applied in machine learning in predictions and all. So basically, I've been able to go through the matrix, but I've not been able to go through the calculus, which is the second week. But at the same time, just like what the first person said, um, I feel like we need more of things or exercises to practice with, so as to so as to be able to remember, or for the formulas or the method to stick and all. So for me, I feel like we need more exercises to practice with. That's all I have to say.
All right, thank you very much for that, Miss Faith. So we'll be looking into that in our next bi-weekly session. Yeah, thank you very much. So in light of that, we're moving on back to the group one. Oh no, sorry, I mean the group two. So for the group two, you guys have lost 2 points right now, and then we have to pick the third person from the group two. So here's a list of the group two, as I said earlier. So for the group two, I think we've called on Mr. Maureen and Mr. John. So the next person should be Mr. Toby Chukwu. Can you please help us with what you've learned for the past 2 weeks? Mr. Toby Chukwu, yeah. Mr. Toby Chukwu, we are expecting your feedback, so you have 3 minutes, which starts now. These females, they are riding us already. Group one is, I think, almost all of them are females, and they are really having more points. The guys, what's happening now? You guys should speak up. You guys speak up. Let them know you're here. Mr. Toby Chukwu. Okay, so Mr. Follow, you can speak while we wait for Mr. Toby Chukwu. Are you? Yeah, you can unmute yourself and speak.
Good morning.
Yeah, good morning.
Please, I didn't hear my name.
The man is here already.
Pardon.
So what do you say?
What did you say?
Come in.
I didn't hear my
I said you
name.
should come again, sorry.
When you were calling people's name, I didn't hear my name, though I joined the bit late because of some other circumstances. So I don't know, maybe I'm in a group.
I'm so Mr. Samuel, can you please hear me? I'm not hearing very well. Can you please type it on the chat, boss? I'm not hearing very well. Thank you very much. Sorry for the inconvenience. So we are still expecting your feedback, Mr. Toby Chukwu. I think you've spent 2 minutes. You have just 1 minute left. 1 minute left, Mr. Toby Chukwu. Okay. Time is almost up. I'm not in any group. Is this because I joined it? Oh, sorry for that, Miss Follow. I just randomly pick people from their responses. So if you like to join any group, would you like to join the group one or the group two? or would you like to help out Mr. Tobichukwu? Yeah, I think that should even be the best option. You can help us with Mr. Tobichukwu. What was the experience from the past 2 weeks, Miss Folongshaw? I think Mr. Folongshaw, sorry for that. So can you help us with your experience? Mr. Samuel, I see you. All right, thank you.
Yes, I can hear me.
Okay, so you can, yeah, I can hear you now. I can hear you now. Yeah, I can hear you. I can hear you.
I wanted to confirm if you can hear me very clearly than the previous times, so I can continue.
Yeah, it's better now. It's better now. I can hear you now. It's better now. So what was the experiences?
All right, thank you very much. First of all, I would like to appreciate you and the organization of this program. I deeply appreciate you. I cannot take it for granted at all. Right. So,
Yeah, thank you very much.
ML, actually, it's how would I put it? This program is really okay for me, right? I think the first one talked about vectors, right? I was able to watch most of those videos, although I've done those ones as basics in undergraduate while I was still, in museum level, I can't really remember. I've done those courses before, so it's actually served as a kind of reminder for me to learn more, and probably by the time I'll start applying to kind of easier for me to, learn, for me to apply, do you understand? Because I've had some basics before. As a matter of fact, the way what's it called, the person, the tutor, right? The way he was taking those courses, the way he was explaining through those graphical stuff, through those video, through those explanations, it really made it much more easier for me because I remember those times eventually it was loads of assignments. We're just trying to solve the problem. Sometimes you may not really tend to kind of look for how to understand, just to meet the deadline and the likes. For the video, kind of more explicated it and I grasped those points pretty well. So for the second part, I had a lot of this, a lot of activities that made my week so busy. I started with the first two videos. I tell you for sure that it was awesome because I told you I've done vectors and also done calculus before. So and I'm looking forward to finishing those videos before the next class because I know we'll be working on the tally sheet and then I take the next one. So it was pretty very okay for me. And that's like I'm again saying once again, thank you very much for organizing this. I deeply appreciate it and I don't take it for granted. I'm looking forward to learning more and exploring and as we proceed in this journey. Thank you so much, Mr. Thompson.
Yeah, thank you very much, Mr. Samuel. That was very insightful and very impressive. Thank you for giving us that type of a feedback. Yeah, so we'll be moving on to I think the group one. So for the group two, Mr. Tobichukwu, Mr. Samuel has come to rescue us. Thank you, Mr. Samuel, because I've been expecting a male to speak up since morning. So next person we'll be having is Miss Nwogu. Yeah, can you please unmute yourself and share with us your experience for the past 2 weeks? Miss Nwogu.
I'm not a miss. So.
Oh, sorry. Sorry for that, Mr. Nwogu. Sorry for that.
My experience is similar to the ones that already came up. I'm still on the matrix and vectors. I'm trying to get to that eigenvalue side. But I learned new stuff about matrices because normally in school it's just how to do the multiplication, which I've forgotten. So, but like I got new insights from it on how it's like transforming the plane and stuff like that. So now I just want to like practice to make sure that I can actually do the arithmetic required for that. But it has been good so far. But I'm trying to rush through this weekend since this last week was busy for me.
All right. Thank you very much for the feedback. So we're moving on to the group two. Yeah, the group one are having upper hand, like backstage the upper hand for the past three For the past three candidates, they've been giving us insights and a very impressive results on their experience. So we're moving on to the next person from group two. Yeah, so we still have 1 versus 3 from group two. So I think there's still a chance for the group two. So we'll move on. Mr. Adepiton Oluwatosin, can you please help us with your experience? Mr. Adepiton Oluwatosin. Okay, so you have 3 minutes and your time. Oh, thank you very much. Let's just. Yeah, good morning.
Good
Thank you very much.
Yes, so on my
Good
hand,
evening.
I started watching the video for the essence of vectors, and literally it just gave me a theoretical knowledge on the practical knowledge I already have from school about vectors. And I also practice solving some dot products, questions, and in general just looking back into linear algebra from from some books. While for the essence of calculus, I've also gone through the video, literally not watching it, but like using notebook LM to assess the contents of the video, since there's no like hands-on math solving in each of the videos. And I just refreshed my knowledge of implicit differentiation, solving using L'Hopital rule, limits, and the likes. Yeah.
Okay, yeah, thank you very much, Miss Oluwatosin. Yeah, so I think there is now a chance for the group two to succeed. Okay, so now we'll move on into the next person, which will be Mr. or Miss. Let's just use that to be a record. Silver side, Mr. or Miss Emumene Owe. Sorry if I mispronounced your name, but please are you on the group to share experience with us? Mr. or Miss Owe.
Yes, I am.
Group
Good morning,
one, they've
Mister.
never fucked up. Please, Miss. Yeah, thank you very much. Okay, yeah, so you can
Okay.
share experience with us. Thank you for joining.
Okay. My experience is similar to everybody's. I was just refreshing linear algebra and unit vectors and the calculations. Really, I know everybody's talking about how they didn't get to practice, so I had a resource that I used to refresh and do the calculations. Really. So it's called Khan Academy. Khan Academy has a segment for linear algebra calculations, and I think calculus, but I've not gotten to that. I've not really dived into the calculus aspect, but for linear algebra, I got to do some of the calculations, and I also watched their videos. You know, it's similar to the one we had with the YouTube one. That guy, it's almost very similar, really. You know, so I don't have much to say, but I did
Yeah,
linear
that,
algebra. Thank
okay.
you.
Thank you very much, Miss Emumene. Yeah. So I think you'll be sharing with us your resource so we can also be like you. We also have to learn from the sites you are using. So we are pleading for you to share with us the link to the resource you are using to solve some of your exercises. So thank you very much. So I think the group one have given us enough points, and also they are also sharing a resource with us. Yeah, thank you very much. So we'll move on into the last person from group two. Yeah, the last person, or last and not least from group two, which is Mr. James Emiade. Yeah, Mr. James Emiade. Group two. Group
Good morning,
two,
everyone.
can you please? Thank you very much. Good morning.
Yeah, thank you. Uh, okay, so I also learned the essence of vectors. I I stayed on that playlist for a little longer than expected because the rate of information, the rate of at which I get new insights from the videos is too much. So sometimes I even have to play it again until I eventually discover that I could just watch it at a slower pace, like reducing this playback speed. So I also learned basically what everybody learns over the unit vectors, dot products, cross products, determinants. I learned um, everything in relations to linear transformation because that's what um, three blue one brown grants wanted us to know, that we don't have to memorize formulas, we don't have to cram them. The determinants can be visually expressed as the area of the linearly transformed combination of vectors, and then the dot product can also be expressed as the one of the vectors on a linearly transformed 1D plane, if I get it correctly. So he just wanted us to know the imaginations behind all these formulas and why we don't have to memorize them. He explained vectors not just as arrows alone, but also as base, what's it called? As basis on a plane and with dimensions. That's the I hat, um, J hat, and for the third dimension, the K hat. And what happens if a two-dimension vector um, gives us a two-dimension vector as an input gives us like a three-dimension output. We talked about that being like the basis of the vector having three coordinates, like 2D slicing into 3D, and all these things are they help my imaginations actually. So um, you also wanted us to know that matrices are not new things from heaven; they can be visualized. So um, all this knowledge were what I have gained so far in 2 weeks. Thank you very much.
Whoa, that was okay. So thank you very much, Mr. James, for sharing your ideas and your techniques. We really appreciate your say to this. Thank you very much. I think you've given the group two a very nice point to deal with. So we are moving on to the last but not the least person from the group one, which is Mr. Michael Olum. I'm sorry for that, Mr. Michael. Let me just use that. Mr. Michael, can you please help us with the summary of the summary you had for the past 2 weeks? Mr.
Okay,
Michael.
sir. Yes, sir. Yes, sir. Yes, I can hear you,
Thank you
sir.
very
I can hear you,
much.
sir. Okay. Yeah. Good morning, everyone. Okay. So, although actually week one is all about that's linear algebra, where I actually play around with vectors and matrices, matrix manipulation, and finding similarity between data points. Yes, that's more like talking about neural network. That's dot product. So I tend to also work around the PCA. That's the principal components analysis, where we're talking about hygiene values and hygiene vectors. Yeah. So and I think still on PCA, I still come across things like dimensionality reductions. Yeah, so which was putting emphasis on technique to actually reduce data dimensions while preserving the most important information. So it's just so what I tend to grab about that was speeding up training and kind of like filtering out noises. Yeah, so the resources that actually helped me out mostly that I tend to got familiar with was the three blue, one brown. Yes, I think it's a series. Yes, it's a series. Yeah. So everything just all about how linear algebraic concept works in ML as a whole. So for week two, I think that's where calculus and optimization came into the picture. Yeah. So where I think they started talking about model. Yes, how algorithm adjust their internal parameters to minimize errors. Yeah. So one of the key concepts was chain rule. Yeah. It actually drew my attention because it was talking about back propagation in neural network, which I was already playing around with in week 1. So that's the process by which models learn from errors. So it was quite interesting to me. So, and also to a part of that, there is the gradients, yes, derivatives and gradients, I think, where it talks about how function changes, how it is being used to actually carry out, I think, flexibility on model parameters, yes, while implementing algorithms. So I think there was cross entropy also, yes, cross entropy, where they talk about that's predictions. Yes, how far predictions are from the actual results. I think something like that, yeah. And still same on that same 3 blue 1 brown series. It actually went a long way. So, and it's actually explained calculus in a visually appealing way. Yeah, so I think that's all. Yeah, thanks.
Wow, that's very, 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 very impressive. Would you like to take the teaching job of email? Like Mr. Michael, you killed it, and that was very, very nice. Even I learned some stuff when you were speaking. So thank you very much. So I think that should be the end of the introduction challenge. So while we wait, I think it's in 2 minutes time we'll be getting a feedback from the grading. Yeah, so I think they are currently grading the 2 groups. So let's give them 2 minutes for them to finalize on that. So I will give a feedback very soon. Thank you for speaking. Okay, yeah, so they are already typing the results, so let me help with that on our chat box. Group 1. Group 2. Okay, so I'm dropping the results right now on our chat box. So congratulations to the group 1. You guys showed an impressive results. Same as the group 2. You guys really, really tried. Yeah, so I love all Yeah, thank you very much. I love the way you guys explained and your observation and your experience and trying to summarize it for us to understand. Thank you very much. Thank you for. So now we move on. So now we move on into the next agenda of today, which is the innovative ideas. Yeah, so the group 2, I think we shouldn't use that same group. So now I'll be sharing us into another group again. Coming. So where did I stop initially? Coming. Don't be scared. No, no. Okay, so 78. James. Okay, so here we go. Mr. Abdullahi Adeni, you'll be group 1. Let me be writing that. Group 1. So let me share the intuition about the next phase, which is the innovative idea. So the question goes and says, the question says, it says, if you have access to an unlimited compute unit in 1 week, what would you build? So like you have an infinite, let me just say you have an infinite access to compute units. You know what compute units are now? Like compute units are the resources you can use in program. Let me just use that for a very layman explanation. Like the resources necessary that you can need, like GPUs and stuff like that. You know, the compute unit for a GPU can be 100 units and stuff based on the subscription. But now they are giving you unlimited compute units for 1 week. What would you build? So in light of that, I'll be sharing the groups right now, so you guys can start thinking about what to build. So as I said earlier, I said the first person in group 1 would be Mr. Abdullahi Adeniyi coming. So very soon we'll be expecting your idea, Mr. Adeniyi, and the next person would be Mr. Oluwatimileyin Oyelabi. So for this session, we'll just be having 2 candidates because of the time. Normally this is supposed to last for 1 hour, so we are already exceeding that time. So for group 2, we'll be having group 2 coming. Group 2, we'll be having Mr. or Miss Praise. Oh yeah, it's Mr. Praise. Mr. Praise Adegoke for group 2. So you can be thinking of the innovative idea you can use the compute units, the unlimited compute units for in a week. Yeah, so next person. Oh, Mr. No. You've given us. I'm coming. Oh, we still need 1 more. Yeah, let me check. Let me randomly select. So, yeah, Mr. Okikiola Oladapo. Yeah, I think Mr. Okikiola Oladapo. You're from the basic or the GenAI? Hello, Mr. Okikiola Oladapo. Are you still on the chat?
Yes, sir.
All right, so I'll be grouping you to the second team, which is the group 2. So thank you very much for joining, Mr. So you have 1 minute left to think about your innovative idea. Okay, Miss Adebola, yeah, you can speak up right now.
Okay, sorry, I kind of joined late. The group, I don't understand how we're selected into groups. Is it something that has been done beforehand?
Okay.
Or you're doing on the meeting?
Yeah, about the grouping is just being done on the meeting right now, just to facilitate the interactive section. It has nothing to do with the study group,
Okay.
so it's just to like, yeah. So you're welcome.
Okay.
So I think 1 minute is up, and then the first person, yeah, thank you very much. The first person from the group 1, as I said earlier, is Mr. Abdullahi Adeniyi. can you help us with the innovative idea you'll be using with this unlimited GPU? Like, I mean, the unlimited compute units. Let me just use that. So what would you like to build with this unlimited compute units in 1 week as an ML engineer? So Mr. Abdullah Adini, you have 2 minutes to answer this question. Mr. Abdullah Adeni, you have 2 minutes to answer the question. Okay, I think 1 minute is out. You have 2 minutes left. Two minutes left, Mr. Abdullah Adeni. What innovative idea would you like to build in a week with an unlimited access to a compute unit? Okay, 1 minute left. Oh, sorry, some people are raising up their hand. Oh, yeah, you guys can speak right now. I think Mr. Debola has spoken already. Mr. Samuel, you have something to say. Please come up with it while we still wait for Mr.
Yeah.
Adebayo.
Good morning, everyone.
Yeah, good morning.
Can you hear me? Okay.
Yeah, I can hear you very well. I can hear you very well.
Okay, I'm so sorry. I'm actually joining this call late, please. I actually don't know what's going on here. I'm lost. Please, I'm just raising my hand so you could actually explain to me, because I've been here, you've been saying someone should come up and present an idea, and I'm confused, please. Sorry.
All right, no problem. Thank you for speaking up. So what we are just trying to do is just to create an interactive section between the students. So now the main idea of this of the grouping is for us to share our ideas, like the innovative ideas we have to we're just trying to test our knowledge on what we would like to build in the future. People have different perspective on what they want to build, so just trying to give a chance for you to be able to resonate on what you can be building in the future. And also the first part of the grouping was to have a summary of what the students have learned for the past 2 weeks. So while someone is being summarizing what he or she has learned, other people can also learn from that. So that was the reason behind the grouping. It has nothing to do with the study group. So it's just to share knowledge within ourselves and also help some people that have not understood. Like some people are even sharing some resources with us, some techniques of us passing through some constraints in the study resources and stuff like that. So that's just the main idea behind the grouping, nothing much. So thank you, Mr. Samuel. I think time is up for Mr. Abdullah. Yeah, you're welcome. So the next person, the question goes to the group 2. Yeah, Mr. or Miss Praise Adigoke, can you please help us with the innovative idea you would like to build with the unlimited GPU? Okay.
Okay. With unlimited GPU, unlimited compute, I would basically build, because my background is in law, so I would build a project that allows one to extract all the laws of the federation, that's like the laws in Nigeria, extract those laws, clean it using OCR. Then I now convert these laws. I train a model also that can convert these laws to machine readable languages. So the choice for me would be Akuma Inotsu, which is the XML language markup, and Legarule ML. So Legarule ML basically allows us to be in formats that, okay, because basically laws are rules and code too are rules. So Legarule ML basically converts laws to a, to a format that, okay, models can use. Then I would use and that, like, basically annotating all these laws, and basically um these laws I would now, okay, train it, fighting it, make a data sets API that's, okay, legal researchers can use to build legal tech products that improves access to justice in Nigeria or in Africa or globally as a whole. Yeah, that's basically what I feel that, okay, unlimited compute can aid to do. Yeah.
Yeah, thank you very much. That's $1 billion idea. So, thank you very much, Mr. Praise. So in light of that, we'll be moving on to the next. I think I have to even learn low. I think the way you are saying it is very, very. So next person I think is Mr. Oluwatimileyin Oyelabi. Yeah.
Good morning, everyone. Please, can you hear me?
Yeah.
All right.
Yeah, we can
Thank you so
hear you
much
well.
for thank you for the privilege. All right. So with unlimited GPU, I first of all I want you to think back to the early days of 2020 when the world was caught completely off guard by a new virus, and we were always one step behind, especially in Africa. We're always one step behind. And reacting to this new variant, reacting to new outbreak, it is evident that Africa is always one step behind when stuff like this, when reacting to medical issues like this. So here in West Africa, this is not actually a new story. So we live in a global hotspot for emerging infectious diseases. So I've thought about this, that what about if a new virus come out tomorrow? What will be the standpoint of Africa? So for decades, we've battled Lassa fever, Ebola virus, COVID, and other pathogens. So our public health heroes at the NCDC and in our hospitals are, I would say, they are world class at reacting to all these outbreak. Even though we know that we are kind of one step behind, we still see the African doctors, medical practitioners still fighting at the forefront of curing any of these variants. But what if we could stop reacting? What if instead of waiting for the next devastating mutation to emerge, we could predict it? So what if we could use AI to see the future of a virus? So this is why the project is called BioAfrica. So the idea is to build a foundational AI model, a genomics prediction engine, which would have been trained on pathogens, epidemic in our own continent. So think of it like a large language model that instead of learning the language of English or Yoruba, it learns the language of viral DNAs and proteins. So this model will be able to do one thing incredibly well, that is predict how virus like Lassa fever, COVID-19 will mutate. So it will identify the future version of the virus and how it can be transmitted, how deadly it's going to be, and the mode of treating it. So now, this is something we can train on our laptop. It requires two things. I discovered that it requires two things, and so our laptops might not be able to compute this massive, what is it called? This massive data. So this is where the unlimited compute for 1 week will become very, very important to us. So number one, the genomic data. We need to train our model on the entire public library of Africa genomic sequences. So decades of data, thousands of viral and bacterial stains. This, what is it called? This access will help us to be able to process this large amount of data, and also structural prediction. So for every potential mutation, there will always be millions of simulation and the 3D shapes of the virus, the proteins, and the like. So these access will help us to be able to have these structural predictions. So we can be able to achieve this in 1 week with unlimited compute, and we won't build a polished app, so to say. So we're able to do something at the MVP stage. So thank you so much. So the name of the project will be BioAfrica, as I said the other time. Thank you for listening.
Yeah, thank you very much. That's another billionaire dollars idea, not billionaire this time. So even if I had the capacity, I would have invested in this idea. Thank you very much for that. So what you're trying to look at will be requiring billions of parameters in LLMs, and I can see what you meant by using accurately the compute unit. So thank you very much for that, Mr. Oyelabi. So we'll move on into the next person from group 2, which would be Mr. Oladapo. Mr. Oladapo, can you please give us a brief of your innovative idea, given that you have the access to an unlimited compute unit in 1 week? Mr. Oladapo.
Good day, everyone.
Hello, Mr.
So,
Yeah, good morning.
yes, giving access to an unlimited compute, one of the projects
Units.
the unit that I would like to work on, that I would like to build will be a chemical plant operation optimization. Chemical plant operation optimization model. I'm currently a student of chemical engineering, so I would like to build a chemical plant optimization, a kind of model that taking like input, like the observation, we train the model with various observable reactions and outcome of um, previously done operations, chemical plant operations, and we train it using those data to give predict to predict to predict possible outcome, and to also give a recommendation based on the outcome to give ways to improve your system, to give ways where you can improve your operations and the like. That is it.
All right, thank you very much, Mr. Oladapo. That was also a very nice idea. So you are aiming at building a recommendation system. Yeah, so that's a very nice idea. Thank you very much. So oh, the time is almost up. It's even up. We've exceeded the time for the general talk. So sharply, sharply. Anyhow, let's just move on to the next topic of today. So there is this topic among ML engineers and AI enthusiasts. So there is this topic that bring out that if you remove vectors and matrices from machine learning, most models still work. Is this statement a fact or a fiction? So very sharp, we won't be taking much time on this, probably just 10 minutes on this, so we can move on to our breakout sessions. So on that, I would like you guys to just give your comments, like give your response on the comments box. So is that statement a fiction or a fact? If you remove vectors and matrices from machine learning, most models still work. So if vectors and matrices have not been found in machine learning, will machine learning exist? So is that statement a fact or a fiction? So we have 2 minutes to think about that and then start dropping our fiction. All right. So let's continue with that. We just need 10 responses, so we can move on, and then I think we are all fine. We have to already 8 more comments, and then we are good to go. Fiction, all right. 7 more responses to go. Oh my god. All right, fiction again. I think majority is carrying the vote already. 1, 2, 3, 4. All right, so I'm lost. Okay, so the question, the statement was that if we remove vectors and matrices from machine learning, will most models still work? Like most models in machine learning, will they still function properly? So now, is the statement a fiction? Okay, you will answer this before I finish. All right. So I think we have 1, 2, 3, 4, 5, 6. We have 6 votes already, so we are left with 4. Okay, I think everyone is accepting that it's a fiction. Nobody's opposing the motion. So 4 more responses, and then we'll move on into our breakout sessions very quickly. Is it a fiction or a fact? Okay, 3 more responses, and then we'll move on. Three more responses to continue. Is it a fiction or a fact? Okay, we already have 1 person opposing the motion, so we still have 2 more votes to go. Okay, so while we wait for others to give us their response, so very shortly, just in 2 sentences or 3, I would like us to support our motive on why we support the statements to be either a fiction or a fact. So we're starting with Mr. or Miss Nwogu. Why do you support it to be a fiction? Just in 2 sentences. Fiction because of this, fiction because of that, or yeah. So Mr. Nwogu.
That did I text it?
Yeah, you can test it, that's fine. So same to others, if you guys can just test it, we just need 3 or 2 responses. So we'll move on very quickly to the next session. Yeah. Fact, I think the model might still work. Okay, good day, sir. Please, I'm having the battery. Don't know if I can go through the recording, sir. All right, so yes, it is being recorded and it will be shared after we've completed this session. Yeah, no, yeah. So thank you very much. You're welcome. Okay, time is fast spent. We are reducing the responses to just 2 left. Okay, models are dependent on vectors. Like K-means clustering algorithm, they group the vectors. That's definition of clustering. Okay, that's very nice. It's fiction because components of a machine learning model, like embedding, have to be represented as multidimensional. That's fine and accurate. Yeah, okay. Fiction because you cannot build something on nothing. That statement is as casual. So if you remove the wings from an eagle, it ceases to be an eagle. It might look an eagle, but it isn't an eagle. All right. So I think I'm also in support of yeah, I love these ideas. This is very, very impressive. Okay, so Mr. Oladapo, you were the only one opposing the motion. So why are you opposing it? Why do you say the statement is wrong? That okay, yeah, it's a fact statement. So can you please support your statements with any points?
I do really actually have utility. I was just thinking
Okay.
that nothing that it all just have to do with like the precision and accuracy of the data. So that was what I was
Sorry, I'm not hearing that very well.
I
Hello.
thought so yes, I am
Yeah, I can hear you now. Yeah, very loud.
I thought vectors and matrices have to do with the precision and accuracy of data that without it you might still be able to get or data, but I later found out that that is not it.
All right. So thank you very much. So we are all still learning, and this was one of the reasons why I brought up about the fact and the fiction session. So thank you all for giving out your experience, your view, and then trying to like make the interaction very interesting. So thank you all for that. And now we'll be moving on to the next phase of our session, which will be the breakout session. So where we're having a summary of what have been taught for the past 2 weeks from our speaker, Mr. Olawale. I think, yeah, he's on the call. Mr. Olawale, what do I mean by Mr. Professor Olawale? I call him a prof. He's very good with linear algebra. So if you have any question, we'll be coming on board very shortly to like give us a summary of what the linear algebra is all about. So we'll be explaining to us in a very simpler term, and then also answering the questions we have for him. So if you have any GenAI students on this group call right now, you all can excuse us for now and then join your main group. Thank you all for joining. Okay. Oh, I missed two more also metric unlock the
Sorry.
temporarily. Wow. All right. Yeah.
Okay. Sorry, I had a question.
Right? Thank you very much. Okay, what's the question?
No, I was about to ask what group is it, but I think they have sent it to the chats.
Yeah.
Yes.
Yeah.
Okay.
Thank you very much. So we have 2 minutes for all the transition. The GenAI students, you all can move on to your group right now, while the MA Basics still remain on this group call for us to have our section with Professor Olawale. Come, let me check him. Yeah. Okay, my prof is here. All right, sir. Good afternoon, sir. So, oh yeah, good morning. Sorry for that. Good morning. So, here is Mr. Professor Ogundele Olawale. is the O1 of the statistics department in University of Lagos. So if you're a student of the statistics department in UNILAG, just hold him tight. Regardless of the level, he's a professor. He can handle any question. If you have any question, this is the right time to bring it up. He has the solutions to it. He's a professor. Professor Olawale, please, let's have it with you, sir.
All right. I'm very honored to be amongst you all. And no, I'm not a professor yet. I'm just a student like every other person. And I must say I've been listening all this while to everything that has been said. And I don't even know if I'm the speaker or I'm a listener at this point because I learned a lot from you guys. So you
Yeah,
guys
thank
have
you.
you've done well. And yeah, I would like to correct another notion. I'm not the OO1 of statistics. That's Timiling. I mean, I'm not the president of the department, but
No, I'm not
that's
talking
my
about the department today. I'm talking about academic.
nah.
All right,
I
so
wouldn't take that into. All right,
all
so
right.
good morning to everyone once again. My name is Olawale. I prefer being called P-Word. All right, so I'm basically just here to summarize. Well, it's impossible to summarize linear algebra anyways. I just want to go on this journey with you briefly and let you know how linear algebra is strongly correlated to machine learning and all that. And I would be very, very open to questions. I love questions and interactive learning. So in a short while, I would be sharing my screen. I have something to share with you guys, just something brief anyway. Okay, so we all know what linear algebra is at this point, or at least we have an idea of what we are talking about when we talk of linear algebra. So can everybody see my screen?
Yes, sir. Yes, sir. You can see your screen, sir.
Okay, so this is linear algebra for machine learning, and linear algebra is a broad field in mathematics, and it's kind of the only field in mathematics that doesn't have a defined definition. And linear algebra is so important in this world because every problem in the world has a linear algebra equivalent. So if you want to do anything in this world in any other field, you can bring it into linear algebra and there will be a solution to it. But let's just restrict ourselves to what we'd be needing for machine learning. So the very first thing is the concept of vectors and scalars. So the first thing you should know is just a scalar is just any number. For now, we'll restrict ourselves to real numbers. So scalars are just real numbers 1, 2, 3, 4, 0 0.5, 1.4. Those are scalars, right? And then the next thing we need to know is what vector. And I watched the material that was sent, the video compilation, the playlist by Theory Blue One Brown, right? And there was this kind of introduction to vectors as the view of a physicist, the view of a mathematician, and then the view of a computer scientist, right? But seeing as we are doing machine learning, the view of a computer scientist is what we tend to lean towards. So what is a vector? So a vector is basically just it's an ordered list. Emphasis on the word ordered. So a vector is just something that helps you compile multiple information in a very compact way. So take for instance, you want to work on house pricing in a particular area, and there's different things that determine the factors of house prices, like the longitude and latitude, the land area, that's the square feet on which it is built. You could as well have the price of the house in itself, how many rooms, right? But all those information are attached to just one house. So in a way, you can say, let this vector represent one house, where you now start stacking information on top of each other. So you can decide to put the square, the land area first, then the price, then the number of rooms, then the longitude and the latitude. So that's what a vector is like, right? So it's just basically a way of representing multiple information at once, right? And how does it relate with machine learning? Well, it's basically the best way to store data. That's what it is, right? It's basically the best way to store data because it's a very nice structure. It keeps everything compact, and then you get to see in real time what you're actually working with. That's that about that. And here's the machine learning relevance. A row in data set is a feature. Like I said, a row is a feature, right? And a column is for one entity. So if you have the columns might represent the houses, and each row would represent a feature for each of the houses, right? So if we have a row that would represent maybe area, another row would represent price, and then it keeps going that way. So that way you know what you are working with, and then you can easily add up, subtract this, that, blah blah blah, right? That's that about scalars and vectors. Something else that we might need to know is what is a matrix, right? So the best way to see a matrix, or at least how I love to see a matrix, is basically just a matrix is now stacking up vectors next to each other side by side, right? So a matrix, like we always say, is a rectangular array of numbers, this, that, blah blah blah. So a matrix is just basically computing or compiling the information of multiple houses in just one structure. Obviously, you don't just be working with one entity. So if you're, I'm going to be taking house pricing as a case study. So if you're working with house pricing, probably have 5 houses you want to talk about. So you wouldn't just say, okay, this vector is for house 1, then you put another vector for house 2, then you put another vector for house 3, another vector for house 4, another vector for house 5. Yeah, fine, that works just fine. But instead of doing that, you can stack those vectors next to each other, right? Stack them, you stack them horizontally next to each other to form a matrix. So that's basically what a matrix is in the sense of computer science and machine learning, right? So the machine learning relevance, as you can see, the entire data set is often stored as a matrix, and it makes so much sense, like I've said. So if you want to look at the demographic data of people as well in a particular country, you have different states. In Nigeria, for instance, we have 36 states plus the Federal Capital Territory, that's 37 states. And if you're interested in total population, number of men, number of women, and children, so we are interested in how many features. We're interested in 4 features. That's the total population, number of men, number of women, and number of children. So those 4 features will each be rows, right? And then the columns will now represent each of the states plus the Federal Capital Territory. So that's going to be, and when we describe matrices, we describe them in terms of rows by column, rows by column. So rows are the horizontal grids, and then columns are the vertical grids, right? So in that case, we'll be having a 4 by 37 matrix. That's basically what we'll be having, right? And one good thing about storing information in this way is the fact that you don't need to put the header. You don't need to put the header. So you just need to have it at the back of your mind what each row is representing. So you just know, okay, row 1 is representing total population, row 2 is representing the population of men, row 3 is representing the population of women, row 4 is representing the population of children, and then you know each column is representing each state. So column 1 is representing the first state, column 2, and that's way, right? So that's the importance of matrix anyways in machine learning. And yeah, there was the argument about taking away matrices and vectors from machine learning. Does it still stand? Well, it stands, but then it becomes very tedious to do, really. So the real reason machine learning and linear algebra are so nice is because, like I said, every problem in the world has a linear algebra equivalent. That doesn't mean without linear algebra you can't solve problems. You can solve problems without linear algebra, just that sometimes linear algebra makes some problem more easy to do than others. Let's take a very good example, which is regression analysis, right? So If you're looking at multiple linear regression, right? Can you do it without a matrix? Yes, you can. You can do it without a matrix, and that's a very good aspect of machine learning. So we all know machine learning is you give your model information, enough information. Whatever you now think is enough is left to you. So that would be determined purely on discretion. And then you now expect the machine to learn from it, make itself better, and predict, right? So it's basically just for machine learning is very similar to statistics. It's basically just for forecast, control, and prediction. Majorly, it is for forecast, control, and prediction. So in this case now, matrix and linear algebra makes things very easy because as when you're trying to like build a model, you don't expect it to work with just 10 data sets, 15 data sets. No, you work with data sets in the thousands. So linear algebra is just linear algebra anyways, compiled or in conjunction with software makes it easy because you just have to do some basic operations, right? It makes the operations basic rather than tedious and complex. Take for example, if you want to build a model um, that predicts the final price of a product being produced by a company, certain factors would be factored in, right? You have things like the price it takes to get the material, the cost of production, the cost of transportation, this, that, and all of that. So you might actually have 7 things factoring or influencing the final product of the price, right? And if it is a linear regression model, that is me skipping a lot of steps, which is, of course, you would have to confirm if it abides by the assumptions of linearity, this, that. But then again, this is not a statistics thing. But if it passes through all those phases untouched and unscaled, then you can use a linear model to start predicting it. Now, what do you do to your machine? I mean, what do you do to your model? What you now do to your model is that you provide it with enough data about certain products, right? It creates a model or a line of best fit or a plane of best fit or a space of best fit. It depends on what you are working with, right? And then it helps you start predicting. So take for instance, you own a company, you've produced 10 products in the past, and then you know how much you sell them. But then you're planning on introducing a new product to the market, but you have no idea how much you should sell it. And you don't want to come off as a greedy person in the market or run at a loss. So you can use a very good model to predict. That's for prediction, right? In the case of weather, you can use it to forecast as well. So you just give your model enough information about the weather pattern, the conditions, and everything that has happened. So with a matrix, the computation becomes easier as compared to doing it manually or doing it with any other traditional method. It's just that matrices and linear algebra makes things very easy. In fact, the word linear algebra basically just tells you that when everything is all said and done, you would be left with a linear equation. So irrespective of how complex or crazy your equation might look, when you introduce linear algebra to it, it reduces it to a linear equation. And that is very evident in the case of system of linear equations. So in a system of linear equations, you can have 3 equations in 3 unknowns, right? But once you introduce it to linear, or rather, once you introduce linear algebra to it, it basically just changes your equation to what? Ax equals v, where A is a matrix, x is the vector of unknowns, and then v is the vector of outputs. And 3 Blue 1 Brown did a very good job at giving the geometric interpretation of all these things and seeing a matrix, a square matrix anyways, as a linear map. And then he explained what linear maps are, and it was very interesting, and you would understand it better if you are a math major or if you have any background knowledge in mathematics, which is a beautiful thing. So that's another way machine learning relates strongly with linear algebra for forecast as well and for prediction, like I said. So let me move on to the next slide. Okay. The next is basically the addition and subtraction of matrices and their implication. Good. So first thing first, a matrix, like we already said, in machine learning, you can store all your data with a matrix. Now, adding and subtracting is easy enough. It is just done position wise, right? So if you want to add up two vectors, you add them components wise. If you want to subtract, you subtract them components wise as well. And why might you be doing that? You might want to get the average price of houses in an area, right? So what you need to do is just add up all the houses, add up all the prices of houses in that area, and then divide by the number of houses. But since you already stored your data in a matrix, does that mean you now start to write the entries manually? No. All you just do is what you add up the matrices to get the sum of everything you have, and then you divide when necessary and all that. So addition and subtraction are used just the normal way we see addition and subtraction, right? That's pretty much it. And then the multiplication and the dot product as well. Well, these ones, they are important, but they have a sort of, it's more interesting when you see it as a mathematical implication. That's the dot product and the cross product. There's also the scalar multiplication anyways. So the scalar multiplication is just increasing your matrix by constant factor, right? So you increase all the elements in the matrix with that factor. That's what multiplication does. It's very easy. But the dot product, like 3 blue 1 brown said, if you watch the video, you understand that the dot product is basically just the length of a vector, right? And when you're taking the dot product of two vectors, it's the length or the product of the image of the length of a vector on another vector and the length of the vector itself. Yeah, it sounds like a lot, but it's very interesting. Anyways, all these things are just the theoretical part. The application is what really matters, and yeah, it's very helpful. You also have some operations that were not spoken about, like the transpose of a matrix, the inverse of a matrix, and things like that. Now, the transpose of a matrix is very important. It helps to kind of create a dot product feeling when you multiply it by itself. So the reason why we need the transpose of a matrix is this simple. You can't multiply a vector by another vector. It's not possible because they wouldn't have the same they won't be conformable anyways, right? They won't be conformable. But when you take the transpose of a vector and you multiply it by the vector, I didn't say multiply the vector by its transpose. When you take the transpose and then you multiply it on the left by the vector, then that's as good as taking the dot product of the vector, and it's a very nice result in machine learning anyways. So I think I'm taking too much time here. I get very animated when I speak about linear algebra. So let me just move on to the next thing, which is an identity matrix. Okay, so what's an identity matrix? Basically, an identity matrix is just a matrix that contains 1 on its diagonal and 0 in every other place, right? And a very good way to see it is to see matrices as operations or as linear transformations. So when you have a vector on a space, right, and you don't want to do anything to it, if you should multiply it by the identity matrix, you get the vector back. So the identity matrix is just an operation that is like doing nothing. So you just don't do anything, but you've done something, but you didn't do anything. Like what you did doesn't have any effect. So that's what an identity matrix is, and it is a very important concept in linear algebra because it comes up in a lot of places, right? And the inverse of a matrix is just another matrix you need to multiply a matrix by to get the identity matrix. So if you are seeing a matrix as a linear map, right? So the inverse of that matrix is just going to be another linear map that would undo whatever the first matrix does, right? So it's just like inverted operations, just like you have plus and minus. So when you add 2 and you subtract 2, you are back to the original number you had initially. So that's what identity and inverse basically entails, right? Now, the machine learning relevance, the inverse is crucial for calculating the closed form solution of linear regression. Yeah, this is so important when it comes to regression. It's very important when it comes to regression. If you take a course on regression analysis, well, linear regression actually, it helps you see how the transpose and the inverse are very good. Like I said, you can do it without a matrix, but then it is very cumbersome, right? Because you would have a lot of data to work with. But when you do it with a matrix, it reduces it to a linear equation. And as you can see, what you have here is just a linear equation. W equals X transpose X inverse X transpose Y. That's perfectly linear anyways, right? As compared to what you would have had if you didn't apply a matrix to it, right? Okay, so the determinant of a matrix, this is another concept I find very fascinating, and I love the way 3 Blue 1 Brown explained it. So the determinant of a matrix is basically just by which factor the area enclosed by a vector is scaled. That's basically what the determinant of a matrix is. So if you should watch that video very well, I think this should just be like a summary of some sort, because if you have a matrix and then you see it as a form of transformation on the linear space, which is the regular x-axis, and the y-axis, the regular Euclidean space, right? The determinant of a matrix is then going to be by what factor is a unit square expanded or shrinked, right? So the unit square is going to be formed by the I vector and the j vector. I and j are the unit vector in the horizontal and vertical direction respectively, right? So they enclose an area of 1 because it is going to form a square of area 1, right? So when you now apply a transformation on it, it changes the whole image. If the transformation is now linear, that's a linear map. So it can be represented by a matrix, a square matrix to be precise, right? And that square matrix is now going to tell you by what factor was the area squared. That's if you are working with a vector that has just 2 coordinates. If it is that of 3, it will tell you by what factor was the volume shrinked or expanded and things like that. And one thing you would notice if you are very familiar with linear algebra is that you can only calculate the determinant of square matrices. You can't calculate the determinant of rectangular matrices. And why is that? Well, the answer is very easy, and it's just about content. So it's like me asking you, if I want to change an area to a volume, what do I need to do to it? I don't know. I can't change an area to a volume. An area is just the amount of substance needed or enclosed by a thing, and then the volume is its holding capacity. So there's no correlation really. So look at an instance. So if you have a 2 by 3 matrix, a 2 by 3 matrix means you have 2 rows and 3 columns, 2 rows and 3 columns. So you can see a 2 by 3 matrix as a matrix that, right, a matrix that takes a vector from, it takes a vector from a 3D space and drops it in a 2D space. So taking it from a 3D space means those 3 unit vectors in a 3D space, the I, J, and K, right, they would enclose a volume of 1, because the volume of a cube is length times breadth times height, which is going to be 1 times 1 times 1, which is 1, right? And then it is going to, in one way or the other, shrink it to a 2D plane, which is just IJ, and it is just going to be able to hold an area. So if I'm asking you, by what factor is a volume reduced to an area? It looks redundant because it's not something you can relate to. I mean, you can't change a volume to an area the same way you can't change an area to a volume or an area to a perimeter, things like that. So that's why it is only possible to calculate the determinant of square matrices, because square matrices are basically transformations that take vectors in an n-dimensional space and still leaves it in that n-dimensional space. So that way, you can be assured that whatever content it was holding will be scaled up or shrinked down, right? And if the determinant is 0, you call the matrix non-invertible. And a non-invertible matrix is basically just a matrix or you can see it as a transformation. It's better if you see these things as transformations, right? So it's basically a transformation that takes every vector in a vector space to a lower level, right? It takes it to a lower level. And then from that lower level, it is impossible for you to go back to the bigger level because you don't know how they got to the lower level, right? So that makes a lot of sense, really, because when you meet a vector in a lower level, you can't tell how it comes down to the lower level, but then you are rest assured that a transformation must have taken place, right? So that's that about that. Let me just quickly finish up on this. Right, so we have eigenvalues and eigenvectors, right? So what are eigenvectors, right? Eigenvectors are just those vectors in a space such that when you apply a transformation on them, they don't change position, they only increase or shrink. That's what an eigenvector is. And then the eigenvalue is now that factor or the scalar by which the eigenvector increases or shrinks. I mean, that's very important as well, and you can read up on the machine learning relevance anyways. I would do well to share this link later on. So the second to the last page. Yeah, so linear algebra provides the language for machine learning, majorly because you'd be working with cumbersome data, and linear algebra is just that guy that reduces everything to something very relatable, and it just makes it a linear equation, and then you can do different operations on it, right? Vectors and matrices are how we represent data, right? So you represent data with matrices and vectors because it's just the right way to go. It's better visualized that way anyways. So that's that about that. Matrix multiplication is the fundamental operation behind neural network predictions, right? Determinants and inverses determine if a model solution is visible or not, right? Yeah, and the last thing is further resources which would help you on linear algebra. I so much love the MIT Openware on linear algebra because it was done by my favorite linear algebra lecturer, Gilbert Strand. He's retired now anyways. He's a professor of linear algebra, right? He understands linear algebra so well, and then his explanation is very, very easy to follow, right? So that's that about that. So I would be taking questions now. So if you have any questions, just do well to ask your questions. Thank you for having me.
Okay, yeah, Miss Sandra, yeah, you can speak up right now.
Okay, can you hear me?
Yes, I can hear you.
Yeah, I can hear you very
For
well.
the section. All right. In the section you mentioned about vector being a data set and then matrix also a data set. So are you saying that vector is same as matrix?
Okay, that's probably a mistake. A vector is a data point. A matrix is a data set. And a vector is a matrix, but not every matrix is a vector. Now let's put it this way. If you are working on a demographic data, I just so much love the demographic data because the features are very limited anyways. So you want to consider the whole of Nigeria, right? And then you want to take a demographic data. So you are interested in the population in each state, the population of men, the population of women, and then the population of children. So you're interested in just 4 features, right? So a data point is just going to be one state, and that one state can be represented with a vector. That's what a vector is. Now, a matrix is now a data set, right? So in that data set, you have data points, which are just the columns. So when you now stack vectors, which are in columns next to each other, it becomes a data point because it's a cluster of vectors. And then it's going to give you a matrix, which is a data point. And like I said, a vector is also a matrix. A vector is just a matrix with one column, right? That's what a vector is. A vector is just a matrix with a column. So you call it a column matrix as well. That's what a vector is. It's just one column. So if you are taking example, If you want to consider a data set that has just one data point, then it can be seen as a data set or a data point since it is just one vector. I hope that answers your question.
Yes, that's fine. So another question is, you mentioned that you can multiply a matrix with a matrix. For example, like if I have like 3 times 3 matrix, I can multiply with the same 3 times 3 matrix, unless I transpose it, right?
No, I didn't say matrix. I said vector. You can't multiply a vector by another vector because they are not conformable. I said vector. You can multiply matrices if they are conformable, but you can't multiply a
That's right.
vector by another vector. Yeah,
Okay.
except you take the transpose of the vector and then you now multiply it by the vector.
Okay, so with that, I don't understand how that works. I would have loved if there is more like, an image or more like a diagram where someone can just look at and be able to understand what that actually means. Like vectors cannot be multiplied by a vector. Let's transpose it. Okay, for example, now if I have a vector,
hold on.
like
I'm sorry, hold
3
on.
rows. 3 rows. Let me get that way, like 3 rows. Then transposing it means it will turn to a column, right?
Yes.
Okay, that means I can. I think I get it now. Awesome, I get it now. Thank you.
Yeah. So what I'm
And
saying.
secondly, the
again,
resources you shared. How do we get it?
I'm going to drop the link. Don't worry about that.
Okay, all right. Thank you.
I'll do the link on the chat room. Okay, so just for clarity, I want to say this. You can't multiply a vector by another vector because they are not conformable. Remember, a vector has just one column.
Correct.
It will have multiple rows, right? So they won't be conformable because they are just not conformable. But if you now want to multiply a vector by a vector, you need to take the transpose, and that's why transpose is very important. So that's going to be equivalent to taking the dot product of that vector. That's what I mean. Do you get?
Yeah, I understand. Yeah, I got it. Thank you so much.
Yeah, you're welcome. Any other question?
All right, so it's almost 12. If you have any question, Professor Wale is here to attend to your questions. Yeah, so we have 2 minutes left for us to end the meeting as, yeah. So any other
Okay,
question,
I can
please?
put a question here in the chat room, which is how do we connect linear algebra to machine learning? Okay, good. So how you connect it is just basically you get your statements problem, right? I'm a fan of research work, right? I'm a fan of research work. So what you do is you get your research problem, and then you now start to ask yourself, how can linear algebra help me in this aspect? So I worked on a project some while ago. It was basically about creating a model that predicts house pricing. It predicts house pricing in I think in a part of Mexico, right? And then it takes in some factors like longitude, latitude, number of rooms, and the area on which the house is built, right? So you already have your problem. You know what you want to do. You basically just want to get the you want to get a model that works. So what you now do is now you have that in hand already. You now need to translate it to a linear algebra problem. Like I said, problems don't come in linear algebra. They come in real world. You now need to like transform it to linear algebra, right? So the problem is now you have multiple factors influencing house pricing. What does that remind you of? It reminds you of regression. Because what is regression? Regression is just basically studying cause and effect. Cause and effect. So cause and effect in the sense that if this house has this, how does it affect the price of this house? If this house has 2 rooms, how does it affect the price of this house? If this house has 3 rooms, what then happens to the price? If it is on this part of the city, what happens? Because the economic importance of some cities is bigger than that of some other cities, right? So all you now need to do is now take multiple examples on those data. So you probably get 150,000 houses, right? So it depends on how well you want your predictive model to be. You know, the more data you feed it, the better it is, the better your model becomes, right? So once you fed it with enough data, okay, for house number 1, this is the price, this is the longitude, this is the latitude, this is the number of houses it has, this is the distance, blah, blah, blah. So if it is a linear model, you let it know you are working with a linear model. If it is a curvilinear model, you let it know it is a curvilinear model. If it is a quadratic model, you let it know it is a quadratic model. So after taking all those data sets into consideration, it comes up with something we call line of best fit. That is, if you are working with just one predictor, one predictor and one predicted. The predicted is always going to be 1 anyways. But if you are working with multiple predictors, it is going to be a plane if you have 2 predictors. If you have 3 predictors, then it goes to higher dimensions. We cannot relate it because we are 3D beings and we don't relate with ideologies that go beyond 3D. But we just accept that it follows the same way for higher dimensions, right? If it is quadratic, you do the same as well. And when you get your baseline model, I'm going to call it baseline model because it can be a line, a plane, or whatever. When you now get your baseline model, using all those data you fed it, right? You can now say, fine, I have my model now. So it's time for the model to start predicting. So you now provide it with certain information that, okay, take for instance, you now go for house hunting in some place, and then you have a model that predicts the prices of house in that area. So you go for house hunting, you go there, you say, okay, this house has 3 rooms, fine, you impute it in your model. It has this, it is located at longitude, this, it is located at latitude, this, it has this number of square units on which it is built on. How much should this house be? Not how much is this house, how much should this house be? So probably your model is now telling you, oh, the house should not be more than 15 million naira. And then the agent of which you go in house hunting with is now telling you, oh, this house is 35 million naira. Then you know that you are being extorted, right? If it tells you this house is going for 12 million naira, then you know that what you are getting a good deal. So that's basically what machine learning is and how linear algebra helps it work so well. That is just one area. Like I said, problems come in the real world. You have to translate them to a linear algebra problem. Good. Another place where you can use linear algebra in machine learning is in statistics. There's this thing we call degree of freedom, right? So using linear algebra, you can make degree of freedom something that is as easy as just a line, basically. So when you have multiple data sets, right, and then you want to create an inference, so basically there's a locality, probably there's a locality somewhere, and you want to say, okay, in this locality they have this river from which they take water. Is the water safe for consumption? That's the statement problem. It has come in another real world problem, right? Is this water safe for human consumption? So what are the things you can do? Well, you start taking samples of the water, you take it to the laboratory, check the antibodies there, check this there, check this there, this, blah, 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 blah. And then you create a model with all the data you must have fed it. So machine learning is just feeding it a lot of data. And then the process of collecting that data is statistics, blah, blah, blah. But what linear algebra now helps you do is that it helps you process that data you must have fed your model with. Because when you feed your model with enough data, computing it by hand is cumbersome. So linear algebra importance there basically is to help you with the computation, right? To make whatever computation it is you have a linear computation, and then you can start taking your inference and then using whatever test you want to use to determine if the water is safe for consumption. Another example is, there are a lot of examples. You can check the effect of social media on students' academic performance. Now, this is not a case of regression. It is a case of correlation. Remember, there's cause and effect, and then there's just relationship. So this is a case of correlation. So are they correlated? Can we assume that social media is having a positive effect or negative effect generally on students? So that's another problem. You need to translate it to what? to a linear algebraic problem. So the major challenge is just creating your model, and creating your model in the sense that, okay, how do I translate this problem to a linear algebra, to a linear algebraic problem? That's where the major job is at, not how does linear algebra help it. So linear algebra just helps it become a very easy thing to do by helping you with the complicated computations. I believe I've spoken well. Thank you.
Yeah, thank you very much, sir. So I think someone also asked a question while you were speaking initially. So we'll just be taking a question for us 2 minutes. So the person was asking, what is the definition of enough data? So in 2 minutes, sir.
Sorry, can you come again? What is the definition of what?
Enough data. What is the definition of enough data?
Oh, what is the definition of enough data? Well, enough data is not something that has a defined definition, right? So it depends on the problem you're working with. Take, for instance, if you want to say, I'm a student of the University of Lagos anyways, so I'm proud of my alma mater. If you want to say, I want to study the effect of online teaching on the students of University of Lagos. Let me now throw this general question out. If I should take a sample of just 100 students, have I done justice to it? No. Why? Because 100 students is less than 10%, is less than 1% probably of the population of University of Lagos. So what I need to do is that I need to take enough data in such a way that it covers everything I need to know, so that I won't be getting a false result, right? If I don't pick enough data sets, I might as well just pick students that are so unserious and then just conclude wrongly. If I don't pick enough data set, I can just pick students that are too industrious and then I will get a wrong conclusion. And that's one thing about and that leads us to sampling, and then sampling is another topic on its own, right? If you should do your sampling well, you can actually pick just 100 students that will still give you the same effect as picking 30,000 students. So it falls down to sampling. So enough data is just when you have taken maybe about, let's say, 30% of the data, and you are sure that yes, it's good enough to work. A very good way to do it is you can do 60-40. So you can give your model 40 to practice with and let it predict the remaining 60. That's a very good proportion. Yeah.
All right, thank you very much. So that should be the final section of it. So I would like to make an emphasis on the last statements of our prof. So I think it was trying to refer to like training the model itself with 60% of the data sets, then trying to like evaluate the performance of the model with the remaining 40%. So thank you all for joining. That will be the end of today's meeting. Join me as we welcome our professor. Let's all thank him for joining and then sharing insights with us. Thank you, Professor Wale. I really appreciate your coming for this meeting. Yeah, thank you very much. So let's call it a day while we meet back in our group chat. I wish you all a nice day, and then that's the end of today's lecture. Thank you very much for joining.